Ancient Sri Lanka has a distinguished hydraulic civilization. Tanks and reservoirs play a vital role in nourishing the Sri Lankan irrigation system. The storage capacity of a reservoir may be required for one or several of the following uses, such as irrigation, municipal and industrial water supplies, power, flood control, sediment storage, navigation, recreation, fish and wildlife habitat, etc. Island can be mainly classified into two zones as wet zone, the rainfall is between 2,500 mm to 5,000 mm, and dry zone, the rainfall is less than 2,000 mm. It benefits from two monsoons and has two crop seasons, Maha and Yala. The Aryan Sinhalese civilization that emerged in Sri Lanka took root in dry zone and they mainly dependent on agriculture. Though the land in dry zone, which extends around the hills from northwest to southeast, was excellent for agriculture, the main problem was difficulty in diverting enough water to their cultivation. As a solution for this, magnificent irrigation schemes were born. Due to less rainfall, cultivations of dry zone are heavily dependent on supplementary irrigation from tanks and reservoirs. Intermediate zone and wet zone receive higher rainfall, which is fairly and evenly distributed throughout the year. This condition permits the growth of crops in these areas without supplementary irrigation. As a result of this, not much tanks could be observed in wet zone. Instead of that, most of the anicuds are there in wet zone. One of the reasons for the remarkable nature of Sri Lankan irrigation systems was use of several hydrologic control structures in building those giant tanks and reservoirs. These structures have a great value as they contribute in controlling the discharge from tanks and reservoirs, mitigation of flood, controlling of erosion, etc. The finest example of the ingenuity of the Sinhalese irrigation engineering is the invention of Piso Kotua in 3rd century BC, which is an equivalent of the modern valve pit, which operates in regulation of the outward flow of water. Walawa River Basin is in the southern dry zone, and the Udawalawa project was started in 1969. Under pre-Mahaweli schemes, Udawalawa is the second river basin development scheme. The whole observation was done along the channel systems which are started from the Udawalawa reservoir. This is a special area, so that it is called as Walawa Special Area. Walawa Special Area is based on Walawa River and it is under Sri Lanka Mahaweli Authority. Main purpose of Walawa Special is providing water for irrigation. A Apart from paddy cultivation, Walawa region is famous for pepper and banana cultivation too. Udawalawa Reservoir and Dam is the heart of the Walawa Special Area. Udawalawa Reservoir was created by constructing the Udawalawa Dam, one of the largest irrigation dams situated in Sri Lanka, in order to impound water from Walawa River. The primary purpose of a dam is to provide safe retention and storage of water. An anecut also has similar purpose as a dam, but the main purpose of an anecut is to divert water. This reservoir provides irrigation to many agricultural lands surrounding the area and also supplies a valuable amount of power to the national power grid through the hydropower stations of the reservoir. The dam, which is 3.9 kilometers in length, has been made up with a gravity section and an embankment section. Mainly, the water of reservoir is distributed through two main canals, right bank main canal and left bank main canal. Normally, in a main canal, it carries about 800 feet per second. After the main canal, water goes to branch canal, distribution canal, and field canal respectively. In one main canal, there are about 8 to 10 branch canals, and in one distribution canal, there are about 15 to 20 field canals. There are two main spillway systems in the reservoir. They are natural spillway and mechanical spillway. Maximum mechanical spillway limit of Udawalawa Reservoir is 88.39 meters, while the natural spillway limit when the mechanical spillway is closed is 88.72 meters. When considering the spillway gate system, it consists of 5 gates which are radial in shape. The length of each gate is 19 meters. Radial gates are one of the regulating structures used, and they can tolerate a high amount of pressure exerted by water because of its shape. The water level of the reservoir is checked once an hour, and when the water level goes up to 88.41 cubic meters, they start to open the gates. First, the middle gate is opened, then the second and fourth gates are opened. At last, the first and fifth gates are opened. This is done to maintain the balance of the water and to protect the gates from subjecting to high pressure. Gates can be operated by electric power, generators, and manually. Manual operation is done when they lose both electric power and generator facilities. In manual operation, to raise 1 inch, 43 rounds should be rotated manually. Glass strips are fixed on the walls of the spill to identify whether there are cracks. The part of the spill have to be dug up to the bedrock. When locating the spill, the conditions of the bedrock have to be considered in order to minimize the erosion. Always a certain amount of water flow should be there from the spill to maintain the flora and fauna ecosystems. In Walawa region, before opening the gates, people are signaled by sirens to get away from the region. Piezometers are fixed in the dam to check fluctuations in water level which seep through the dam. This can be observed in both Walawa Dam and Chandrikavawa Dam. Normally, the readings are gained weekly from the piezometer. Tip meter is used to measure the water level. The seepage from the dam is known as tow drain. In order to measure the seepage or the amount of water discharged through the dam, V-notch is used. Bypass gate is one of the regulatory structures that can be used to send the excess water from the main canal to the spill path once again, and it also can be known as one of the water management processes used. Most of the bypass gates have a radial shape. Level crossing is also another regulatory structure which traps sediments and reduces the velocity of water. Many emergent plants grow here due to the high nutrient content of the trapped sediments. To rehabilitate the level crossing, desiltation should be done. Level crossing is a similar regulatory structure to Kuluwawa, which was functioned in the ancient times. When comparing with the Kuluwawa system, this is not an efficient method as the rehabilitation should be done regularly. Andhrawawa is the last level crossing of the left canal. Culverts are used to carry water across roads. When water has to be carried across a road which is at the same level or below the canal bottom, an inverted siphon is used instead of a culvert. They also can be used to carry water across wide depressions. This structure consists of an inlet and outlet connected by a pipeline. The inverted siphon, which was observed during the field visit, was created by crossing the Rakwana Ala, and the aqueduct observed was created by crossing the Magalara. Flumes and weirs are another type of regulatory structures which are used to measure the water discharge. The principal objective of measuring irrigation water is to permit efficient distribution and application. In these structures, Water depth is read on a scale which is a part of the structure. Then, using the reading, flow rate is computed from standard formulas. Among the spills located associated with the canals, Morning Glory structure and Labyrinth spillway plays a special role. Morning Glory structure spills out the excess water, and this can be used to minimize the damage to downstream structures if more water comes to upstream. A labyrinth spillway can be seen in Andhra. It is a type of spillway in which the weir wall is constructed in a zigzag manner in order to increase the effective length of the weir crest with respect to the channel width. When considering these hydrologic control structures, it is obvious that they play a major role in distribution, regulation, and water management in reservoirs and associated systems. Having an understanding about the functions of these structures will be much more helpful for the future generation to apply their knowledge to innovate new things regarding these hydrologic control structures. It is our prime duty to use these structures sustainably and to protect them for the future of Mother Sri Lanka.